Today we're going to do our third type of transformation, and that is rotations. Gosh, I haven't even started yet and you're already yawning. Cut me some slack. A rotation. Now this one, like the first two, like translations and like reflections, after you perform the transformation, it produces a new figure exactly like the original. So they should be congruent. Another name for rotation is a turn. Under a rotation, a figure is rotated or turned about a given point. That's very important. It's turned about a given point. So kind of like you ever watch a CD spin in a CD player. That CD is being rotated about that center thing that pops up, that little cone, spins about the given point. The majority of our rotations we will concentrate on, the center of rotation will be the coordinate 0, 0. A complete turn is 360 degrees. Why would that be a complete turn? Yeah, there's 360 degrees in a circle, right? A half turn 180 and a quarter turn is 90. A rotation has three crucial pieces of information that we need to know before we can perform one. One, we need to know the center of rotation. Usually it'll be 0, 0 for our purposes. We need to know the amount of the turn expressed as a fractional part of a whole, right? So if it's a 180, what else could I call it? A rotation of a half. If it's 90, we could call it a quarter turn. Or as the angle of degrees, angle of rotation in degrees. This is what we will normally use, angle of rotation in degrees. And then the third thing we need to know is the direction of rotation, clockwise or counterclockwise, which is sometimes the topic of great frustration among students. And I'll see them sit there and look up and start removing their fingers, which will work. However, I want to point out something that you can use in your environment. Everybody look over there at that square thing with the circle in the middle and the hands on the wall. That's what clocks used to look like before they were digital. Alright, I know you laugh, but some people, young children especially, they get to a certain point and they can't read a regular clock because they grew up with digital clocks. That is a clock. That's an old-fashioned one, I know, but see the little red hand there? This is where you shake your heads up and down. Yes, you see it? Okay. See the way the red hand is going? That's clockwise, which means the other way is counterclockwise. So if you forget, use your contextual clues, your environment. I won't say don't look at the clock. Go ahead and look at the clock. It's not a problem. That way is clockwise. This way is counterclockwise. If you have a watch that has the hands like mine I'm wearing today, you feel free to look at that. Alright, these are our rules. Now these rules are specifically for those about 0, 0. And they only work when the center of rotation is 0, 0. However, like I've said before, the majority of cases we will have this year, the center of rotation is going to be 0, 0. First one, 90 degrees clockwise spin. A 90 degrees clockwise spin. What happens is you have your original coordinates. The new coordinates you will change places just like we did in the rotation with y equals x, or the reflection, I'm sorry. But after you change them, the original x, which is now your new y, you change its sign. Because what's happening is if it's 90 degrees clockwise, if it's in the first quadrant, it's going to the second quadrant, which means your y coordinate is going from positive to negative. Your new y is going to be negative. The next rule, 90 degrees counterclockwise. So this is going that way from like quadrant 1 to quadrant 4. You'll change their places, so the y will become the x will become the y, and your new x, the old y becomes negative, or you change its sign. Now realize you change the sign. That doesn't mean it's always negative, because if you start with a negative 1, it's going to make it positive. The next one is 180 degrees clockwise or counterclockwise. Why would it be both? Yeah, halfway is halfway. Either way you go, you're going to end up halfway, right? Exactly. Doesn't matter which way you go, 180 degrees, you're forming a semicircle, so that's halfway around. And what you do is the coordinates stay in the same place, you just change their signs. And we have one more, and this is my favorite rotation personally, and usually it's students' favorite rotation. What is it? What's that? 360. Why is it everybody's favorite rotation? You don't have to do anything. That's right. Nothing changes. Why? Because you finish where you start. It's one complete revolution. Yes, you will have at least one of these on your homework. That's everybody's favorite problem all year. Those are the 4 rules. You want to make sure you commit those to memory. I'm sorry? You're not a day late, you're 2. You're not a day late, you're 2 days late. All right, we have a triangle, and it's a rotation 180 degrees clockwise, about 0, 0. Now, before I even start graphing the original, since it's 180 degrees clockwise, I have a rule. The rule tells me to do what? Change the signs of the original. So Q prime, I'm going to map out where the rotation is going to be. Q prime is going to be at -2, -4. R prime is going to be at -1, -1. And S prime is going to be at -4, -1. So what's going to happen here is we're going to start here at 180 degrees. Now this, it's like taking a piece of string and having a pencil on the end of it, and it's going to start here and swing all the way around like that. You ever done that to make a circle? Take something, set it in the middle, take a pencil and piece of string, hold the center, and then make a circle that way? That's what what's that? The spinny thing, called a compass. Have you ever made a compass, used a compass to make a circle, Marcus? Alright, this is the same thing. When we do a rotation, it's like that. Bless you. That's what's going to happen. Alright, my original Q is at 2, 1, 2, 3, 4. R is at 1, 1. And S is at 4, 1. Q prime is at -2, -1. R is at -1, -1. And S is at -4, -1. Does that look right? Should be upside down. That's in the right place. It's rotated 180 degrees. And one way to check it is to make sure R and R prime are equidistant from the origin. Yep, they're both one corner, one block away from the origin. Okay. Now we're going to have a 90 degrees clockwise. So I don't know if you've noticed, what was the first thing I did in that first one? I found my rotation and my center of rotation, right? I found what I was going to do. Because I'm not even going to do any graphing until I know what all my coordinates are. That's what we do when we rotate. Unlike the translation where we went ahead and we had to plot it and then count. The same thing with the reflection. We plotted it and then counted. Here, I'm going to make sure I have all my coordinates in place. What's the rule for 90 degrees clockwise? I take the coordinates and change their places, and then which one becomes negative? The old x, which is the new y. Isn't that it? 90 degrees clockwise. Yes. The original x, which is now your new y, I changed the sign. Right, so A prime, switch their places. And then the old x, which is your new y, I changed the sign. B prime would be 1, -5. And C prime is at 1, -1. Right, the original. 1, 1, 2. There's A, B. All right. What kind of triangle is it going to form? Don't everybody shout right triangle at once. Okay. It's a right triangle, right? Yes, it is. Oh. It's always a critic in the crowd. Are you you okay now? You talk about me being obsessive, compulsive. Sheesh. All right, A prime. Now, what should this look like when it's done? 90 degrees. What will happen to it? No, not half. 1/4, right? So it's just going to point down. All right. I like to visualize that before. When after I get my original, I think, well, if I did it right, what should it look like? That way I know once I get it graphed whether or not I did it correctly. A prime is at 1, 2, 3, -1. B prime is at 1, -5. And C prime is at 1, -1. Okay. That's what happened. Turned it down 1/4. So it's pointing down now. Okay. We could also use the rules given something like this to figure out its original, correct? How would we do that? If we were given the coordinates after the rotation, how could we figure out the original coordinates? Yeah, reverse the rule, right? Exactly. A large mechanical shovel is used to move gravel. If the coordinates of the shovel are A, 0, 0, B, -2, 2, C, -4, 4, and D, -4, 2, after being raised by a 90 degrees clockwise rotation, about 0, 0, what were the coordinates in its original position? So we could reverse the rule, right? Or we could do what? This is a 90 degrees clockwise. So 90 degrees clockwise. We take X and Y, and they become this. So what would we have to do? Take this Y, take this one, move it over here, and then put another negative sign in front of it, correct? Right? And then take this one and move it back, the Y. Well, that's the original A. That would be easy because 0, 0 is still going to be, yeah. If your center of rotation is 0, 0 and one of the coordinates is right at 0, 0, that means what? It's not moving any of the way, right? Because that's it right at the center of rotation. The original B, these two would change places, and this is going to be -2. So it's -2, -2. The original C is going to switch places. -4, -4. And D would be -2, -4. What's the rule for 90 degrees counterclockwise? What do you do when you have a 90-degree counterclockwise? What's the rule for that one? Take X and Y and you do what? Flip them and change that one, right? Huh. Well, after 90 degrees clockwise rotation, how would I move something back? By doing a 90-degree. Could I have done that instead? Could I have said, hey, since I'm going backwards, I'm actually doing a 90-degree counter. Would it have given me these results here? Would it? Let's figure it out. You think? Well, 0, 0. That's not much of a guide, is it? 0, 0. But this one. If we start with this B and then apply the 90-degree counter, assuming this is the X and Y, we'd change their places, and then this would become negative. This one right here. Yep, it would work, wouldn't it? Change their places, make that one. It would have worked all the way through. So there was really two ways to do this. Why? Well, when you look at the rules, 90 degrees clockwise and 90 degree counterclockwise, what are the rules? They're opposite of one another, right? Because those are opposite rotations. So that's what they really are. The other thing you'll have to do, very limited, I don't like to do a lot of this, is identify the center of rotation, the angle of rotation, and the direction of rotation. Mainly I do these just so I want you to picture or figure out which one's the original and which one's the rotation. Mostly I'm not real super concerned with the center of rotation, just basically the direction and the angle, or the number of degrees. Now this one, where am I starting? The one that faces up or the one that faces sideways? Sideways. How do you know that, Chris? You were correct. It doesn't have the prime marks. Very good. So to go from here to there, what part of a circle is that? Well, let's complete the circle. Or we could even take and put a circle in there. We started there, it ended up right there. That's not a very good way to see it, but it kind of looks that way, doesn't it? That's because I was off when I did it. But really, when you start here and just end up right here, well, the way I like to think about it is you're starting there, right? With this line, and you're ending up right there. So what does that make when I draw that? 90. That's 1/4 of a circle, right? So it's a 90 degree, and which way is it? Use the clock. That's what it's there for. This is a 90 degree counter. Very good. How many answers are there to this problem? There are 2. Could it be the other way? Sure. You could have said, well, I'm going to start here. See if I can get a color that we haven't used. I'm going to start right here and go this way. So you're going to end up with that. So Brad, what's the other acceptable answer? 270 clockwise. There is something on the test like this, and the reason why I like this question, there are 2 right answers. So the counterclockwise, the clockwise, you pick one. What's the important part? Making sure you get the correct degrees. Yeah, the correct number of degrees. That's the other thing you'll have to do on your homework. And all I'm concerned about is the direction and the number of degrees. If it's 180, is there a wrong answer? If it's 360, is there a wrong answer? No, because both of them, doesn't matter which way you go, you end up in that place. So the 90 and the 270 are the only ones. So of course, let's think critically. If I were a math teacher on the test, what would I put on there? The example that there's no way I could get a wrong answer, or would I do the other one? Yeah, one would think. Right. Pages 308 and 309, 1 to 18 all.